So my name is Eric Postma. I'm the Director of Mathematical Development at Maplesoft. And today I'll be talking about our work on AI-powered document generation. So this will be in part about stuff that's new and in development. So that means there will be this is not, slick work that is guaranteed to work, as when you're working with AI is mostly the case. So we'll see. Look out for um, um, things going wrong. That will be expected. But I hope that you'll see something interesting. Just one item I really enjoy when I give presentations, if people have questions, if they let me know straight away. I love responding to that in the moment. So we'll try the rule of, if you have a question, then just speak up, and we'll see how that goes. We may switch to questions at the end if there's too many. All right, so a bit of a layout of the talk. First, I'll spend a few minutes on history of what we've been doing with AI over the last couple of years. Give you a little bit of details of some of the earlier projects we've done in the past couple of years. And then there are two items that will be new in Maple 2026 that I'll show. So I think the very first thing that I've seen here within Maplesoft, where we were thinking about working with the sort of current crop of large language models, was in an internal Slack discussion where our CEO, Laurent Bernardin, mentioned that he'd worked up a worksheet for interacting with GPT-3 in February 2023. So that we took that worksheet and polished it a bit, and then a little bit later we published that on Maple Cloud, sent an announcement on Maple Primes, and we added that. And the sort of the next full release after that was Maple 2024. And there we added a feature that we called the AI Formula Assistant. So I'll talk briefly about what that does in a minute. Just to establish the timeline, the next release after that was Maple 2025. And there we worked on Maple document generation. We built that feature, but we felt it wasn't quite slick enough to be sort of a full advertised feature, in particular because we didn't have time to build a good user interface for it. So we released that as part of the product, but we released it as sort of a technology preview. And so that's what we've released in this field so far publicly. And in Maple 2026, we'll see some other things that I'll show you in a minute. But to keep it exciting, I won't reveal it yet. I'll first talk a little bit more about the things we've done in the past few years. So a little bit about the AI Formula Assistant. So I'll first show you what it does. So if I click here, there's a tab called AI Formula Assistant. And I can enter some keywords here. For example, if I want to, I remember there is a formula in graph theory that relates vertices and edges, and the number of enclosed areas. Suppose I don't remember the word faces. And in a planar graph, then I can ask the AI formula assistant for formulas related to these concepts, and it'll come up with 5 equations that relate to this. Let's see, actually, that in this case, that didn't work, so I'll try that again. In the meantime, I'll just talk very briefly about what goes on behind the scenes here. I won't go into this in detail, but we basically take the user's query with some general instructions and send it to an LLM, accompanied with very detailed instructions on how to represent a whole bunch of different mathematical constructs in Maple. That comes back. We split it into 5 blobs of text, and it turns out when we did that, generally the equations that come back still can't be parsed by Maple. We have to ask the LLM again to really apply those instructions, and then usually we can parse it with some effort. All right, so we see here that we've gotten a bunch of formulas back, including the one that I was looking for, Euler's formula, v minus e plus f equals 2. So there's a bit of explanation here of what the symbols mean in the equation, and importantly, if I'm here in my Maple document, I can click Insert Formula, and the formula gets inserted. And there's a bunch of other formulas here that also relate to this. Yeah, so sometimes, yeah, okay. So I won't go into too much detail here. Just as a rough estimate of how much work is in here, this is about 650 lines of Maple code. And my coworker Michael Denny in the GUI group wrote almost 2,400 lines of GUI code to make this work. And about half of the library code is in this little diamond here, saying, can we parse the given equation? And very carefully trying to parse bits of it and correcting problems. So the fact that that was so tricky prompted us that the next year for the documentation, for the document generation work, to use a different way of representing Maple expressions, and we chose to use LaTeX. But first, let me explain a little bit about the general setup. So for this work, was the first time that we really supported a dialogue between the user and the LLM. Yeah, I won't go into too much detail. There were a number of different commands that build upon each other. So the dialogue command is sort of the most low-level command for having a dialogue with an LLM. On top of that is a command called generate document, which takes a user query and some settings and asks the LLM to create a markdown document. Markdown is a format in which documents, a sort of lightweight format for formatting documents that LLMs really like to work with. And then we wrote code to translate that into a Maple worksheet. And then finally, we added an interactive front end on top of that. But this is not GUI code. This is Maple code that uses the document tools package, so that the user can have, buttons and text fields and things like that to call generate document in their worksheet. So no GUI code at all for this. other than through the use of the document tools package, of course. Much of the code here was in the Markdown document translation stuff. So it uses an open source Markdown parsing library written in C that was pre-existing. Then we wrote a glue layer of about 1,500 lines of C++ code and about 450 lines of Maple code that can do that step. Okay, so far, the history. Now I want to talk about the future. The first item that is new in Maple 2026, I think Laurent mentioned it already briefly, is we now have, and by now I mean in this development version of Maple that you see here, we have a facility for PDF import. So this is typically something that's really hard to do as part of a the traditional algorithm to generate a sort of reasonable layout and things like that from a PDF, but LLMs do have the ability to really read PDFs and extract reliably and reasonably reliably extract information from it. So we found an external service that uses an LLM to turn a PDF into a Markdown document. And we hooked that up to the code that I mentioned in the previous section. With about 250 lines of code, we can now do the following. So let me show you a PDF document that I generated specifically for this demo. It is extremely simple. It has a table in it with a line of headers, and then some numbers and some formulas in it. And I'll show you what happens if we import this. So I'll switch back to Maple, and I'll run this command worksheet from document, and that will open this table here, and it has the same headers, Fred, Mary, and Pete, and the same numbers and formulas in it. And these are just regular Maple formulas. So this gets interpreted in a nice way. Okay, so you excited yet? So this is one project that's slated to go into Maple 2026. I want to spend the rest of this talk on the other item. So we call this the AI assistant. Let me first show you what it looks like. So it lives here in this sidebar. And here's how it works. So I can type a message to the AI here. And when I hit enter, you see there's a little animation here, which means that the AI is thinking, or not really thinking, but it is busy. And it comes up with the old scarecrow joke that everybody's heard 1,000 times before. So for this, you don't need Maple, of course. You can get this in 1,000 different places on the web. But it becomes more interesting if we ask something like, how does the PyTix option work? Plotting. So what goes on behind the scenes here? So you are already getting a behind the scenes look in the sense that this is new technology that we're working on as we speak. But I want to give you an even more behind the scenes look. So I'll show you screen full of gibberish nonsense. But I want to draw your attention. So this is some logging output that you won't be able to see if you run Maple once this is complete. I want to draw your attention to the last few lines here. I'll scroll up because it has new things have happened. So it talks about searching the help page. And indeed, if we go back to Maple, we can see, let me share Maple again. There we go. We can see that we get some output here that has really detailed information about the use of this relatively obscure option for the Maple plotting system. So what goes on behind the scenes here is that we've given this tool the option of using Maple's help search. So let me talk a little bit about how this works under the hood. So there are 4 different items of input that the GUI sends to the library whenever I hit return or press a button here to do an interaction. There is the text of the current worksheet. There is the text of the current selection in case the user has selected something that might be relevant. The LM might need to know that. There's a textual representation of the current global variables and their values. And there is sort of the pre-existing dialog history, including the current user query. And the first 3 of these we don't automatically send to the LLM, but we provide it as a tool, which is basically a function that the LLM can call. And there's another sort of hard-coded tool which is for searching the Maple help system. And then we have a bunch of sort of hard-coded instructions and examples, and we send that to the LLM, and it sends us some output. And that output can be of 2 types. So this is a very standard setup. It can be a so-called tool request, which means it wants to run one of these 4 items, in which case we execute a bit of code and send the result back to the LLM. And we keep going like this until after, well, usually 0 or 1 of these tool calls, the LLM gives us some output for a presentation to the user. And this output comes in a number of different types. So there's sort of the like the banter, the conversational stuff that the LLM has as sort of part of the dialogue where it's talking with us. There are fragments of Maple code, like this one here, and what you can do with that is you can just insert it into the worksheet. So if I go here and I click this button here, I get a code edit region, and I think there's, yeah. Okay, let me see what happens if I execute this. So we get a bunch of plots here. And this has the explanation of, so this is kind of funny as well. If you want to if you want to plot the sine function and have decimal numbers on the horizontal axis and multiples of pi on the vertical axis, this is one of the examples that Maple gives us here, or that the LLM gives us here, rather. Who would want that? I'm not sure, but that's the explanation. So there's this format for a bunch of different types of content that are mixed, and what goes on behind the scenes is that the user's worksheet is translated to HTML, and that is sent to the LLM. And what the LLM sends back is also HTML, and we translate back to Maple worksheets. Okay, so I wanted to show you one somewhat longer example. And for that, I'll start a new dialogue here. And the query I want to start with, I've pre-prepared here. So I've run this. I've run this a number of times over the past couple of days, and sometimes it goes really well, and sometimes it goes okay, but it could be better. So we'll see what we get. So the first prompt, what I ask of the LM is to help me design a lesson plan for use substitution for first-year university students. And I want it to ask me one question at a time. So we'll work on this and we'll see what comes out. Let's see. So the first question is, what's the format? So we'll say 150-minute session. So this is pretty short, but I don't know. This is what I asked. So then it asks about what prior knowledge do the students have, differentiation, and antiderivatives for polynomials. Can't quite spell, but that should be okay. X trig and 1 over x. So this way we get sort of a dialogue going, and generally at the end I get an idea of I hope to get a sort of minute-to-minute plan of what I could talk about. I can. So now it asks about what resources I have. I can present Maple code projector, and let's say the students have clickers. So clickers are the type of yes, no, or multiple choice selection items. So now, what learning objectives do we want? Well, maybe we find first priority, recognizing when U sub is appropriate. Second, applying U substitution in indefinite integrals. Third, applying in definite integrals. So I'm treating it as sort of a partner to think about this with. So let's see. I'm just giving some answers to see what the LLM will come up with. It's been my experience that detailed plan with quicker questions and available minutes. So when I get to the point where it needs to generate the actual detailed plan, it takes a little while. So that could be a minute or so. And given that it's already been about 30 seconds since I hit enter, I think it's probably working on that now. So we'll see what comes out of this. Generally, I've gotten decent plan out of this. I mean, it still needs manual refining, of course, but that's to be expected. We have our expert teachers. This is just to take a little bit of the effort out of your hand of coming up with a plan like this. And yeah, so could take up to 2 or so minutes for the final result to come. Okay, so let's see what we've gotten here. I'll make this a bit bigger so that we can see a bit better. Scrolling up. Okay, so here's a summary. Basically, the answers to the questions that I've answered. And here are the suggestions. So here we have a minute-by-minute plan. You'll notice that there are some question marks here where there should be certain symbols that it's not quite translating correctly. So that's something that we'll still work on. So let's see, does this make some sense? Quickly state the learning goals, show the chain rule, derivative examples, and invert them. Yeah, that's a good approach. Concept and formal justification. And do 2 short instructor-led examples. So I think those come further down. And we do a clicker, discuss some common mistakes, and talk about definite integrals, slightly harder examples. Yeah, so I think this is a reasonable setup given the constraints that I gave. Okay, here we have everything in a bit more detail. Let's see how much time. Yeah, we have not much time left, so maybe instead of going through the details here, which we can maybe make available elsewhere, I'll see if there are any questions. Austin, did you capture any questions that would be useful for me to answer?
There were 3 relevant questions in the chat. One was, is there any fine tuning on the LLM with the Maple data?
We've looked at that. We've played with it. We did not see a huge improvement. We noticed that the improvement for giving access to the help pages, to help page search, so basically RAG, gave us a lot of sort of bang for the buck. It's relatively easy to add, and it showed really good improvements. We tried some fine tuning, and the results did not really were not really worth it.
Okay. Second question was, and I believe this came up when you were importing the table from the PDF.
Yeah.
Why did Maple not understand the power and then reformat it? Now, I didn't notice that, and
Right.
I'd have to go back.
I think I can show that. I hope this is the right. Oh, this is not the right. Oh, you know what? I closed that document, but it's pretty quick, so I can bring it back up, I think. Here we go. So I think the user is asking about this x squared minus 1 here. Yeah, we haven't done that yet. I know where we would need to. So what happens is I'm almost sure what happens here is that the code that comes back from the external service that I mentioned has this formatted as a LaTeX formula. And in Maple, if you do LaTeX. I think this is the correct syntax. Yeah, okay. So actually, if I demonstrate it here, it will do it correctly, I think. Yeah, so this gives the MathML for this. The translation from MathML to an actual typeset formula is where we would need to implement that. So yeah, that's a good suggestion. We can see if we can get to doing that. Note that this is correct. This evaluates correctly. If I take this formula and it's currently, I think, non-executable math. But if I switch it to executable math and evaluate it, then it evaluates to x squared minus 1. So it's purely cosmetic, but it is important. So yeah, we'll see if we can fix that.
Okay. The next question is, does the LLM incorporate Maple Prime's content into its answers?
Currently, not explicitly. I mean, Maple Prime's content is public, so it may well have been used during the original training of the LLM, but we don't explicitly feed it in.
I think you could, if you wanted that, you could certainly ask for it, right? As part of your question.
Yeah, I don't think that would work because we don't offer a tool for web search
Oh,
to the
okay.
LLM. Yeah.